Okay, so we're looking at the last video in the series on trig, and this time it's the applications into what we call periodic phenomena, which are the real world applications of trigonometry. So many natural things are periodic in that they repeat, and as such they can be modelled by trig functions. And I cannot think of a single example of tan. They're usually sine or cos. And some examples in real life that we're going to look at: tide heights and sunrise sunsets. But we'll look at just one example on the next page. But they're the normal applications. So come across when you're ready. Okay, so I've got an example here. The height of the tide above the mean sea level, not above the sand, above the mean sea level, is given by that formula, where h is the height above the mean sea level in metres and time is after midnight measured in hours. So I've got a series of questions. So what was the maximum height? When was the maximum height? What was the tide height at a certain time? And if the boat needs to be 1 metre above the sea level to get out of the harbour, when can this occur? Okay. So we're going to start off with just having a look at the function. So we know that that's a sine curve, and any sine curve has that sort of shape, and the maximum height is given by the number out the front. So the maximum height above the mean sea level is going to be 4 metres. So it's not the maximum height is 4 metres, it's the maximum height above the mean sea level. Okay. So when does this occur? Okay, so now we have to solve an equation. So we've got 4 equals 4 sine pi t over 6, and then the 4's just cancel out. So now we have to think about, when does sine equal 1? So that means that sine of pi t over 6. So when does sine equal 1? And that occurs at 2 times. We've got pi on 2 in the first lap, but we've got to remember that there's going to be another tide as well. So there's only one time that sine is positive 1. So we need to look at another lap around the circle, and the second lap will be 5 pi on 2. So actually, beg your pardon, I'm going to change that. So that should be just, I'll get rid of the word sine. So pi t on 6, because I've inverse, oh sorry, take that back. So I've inverse sine of 1. Okay, I've inverse sine of 1 to get those two numbers. And so t will be pi on 2 divided by pi on 6, and 5 pi on 2 divided by pi on 6. And that gives me 3 and 15 according to my calculator. And so the 3, therefore the times after midnight will be 3 AM, and 15 hours after midnight will be 3 PM. Okay, so that makes sense. There's 2 tides at maximum. Okay, next one. So let's have a look, change colours just to be different. What was the tide at 8 AM? So the height after 8 hours equals 4 sine pi times 8 over 6 equals 4 sine 4 pi on 3. Okay, now 4 pi on 3, you've gone past, so it's going to be negative. So it's going to be negative 4. Now, sine of pi on 3 is going to be root 3 on 2. So that ends up being minus 2 root 3 metres. So at 8 AM, height is minus 2 root 3 metres below mean sea level, whatever that is. Okay. And let's have a look at the last question. Okay. So the last question, we need to find out when the height is going to be equal to 1, so that we can work out when it's going to be above 1. So we've got sine pi on t over 6 equals a quarter. Now sine being positive happens in all stations 2 central. So we've got 2 answers on the first lap and then 2 answers on the second lap. So pi t on 6 equals inverse sine a quarter. And in radians, so go make sure you calculate in radian mode. So we end up with 0.2526, and that's the first quadrant. So we're looking at 4 answers. We've got first, second, and then fifth and sixth. So first and second is in the first lap and the second lap. Okay, then on the second lap, it's going to be pi minus 0.2526. And then on the fifth lap, it'll be 2 pi plus 2.2526. And on the sixth quadrant, it'll be 3 pi minus 2526. Okay, so then the times will be, so you'll get these answers, and then you're going to multiply by 6, and then divide by pi. Okay, so all of these answers that we've got here, 1, 2, 3, 4, we're going to multiply by 6, and then divide by pi, and get some new answers. And those answers, I've done on my calculator already. So I get 4, 8, 2, 4, 5.5176, 12.4824, and the last one, 15.5173. And then these are all times in hours, so that's going to be 29 minutes, 5 hours 31, 12 hours 29, and 15 hours 31. And again, knowing that the sine wave is like that, it's going to be above in between the times. So therefore boat can go and return between these two times and these two times. So any time between 12:29 a.m. up to 5:31 a.m. and then 12:29 p.m. and 3:31 p.m. So I don't think I've made any mistakes, but if I have, I apologise. But you can just check those calculations, but I think they're the right answers. I'm just a bit worried that there's a 3-hour gap there and there's a 5-hour gap there, so I'm thinking I might have made a mistake with one of those numbers. But if you can just check those calculations, or I might have made a mistake with those ones, but that's going to be close enough. The idea is important. And there's a worksheet on Moodle, so enjoy. That's it, bye.